Welcome. I'm Andrew, and we're going to have a little walk down memory lane. This is a history of infrastructure as code, sort of, kind of. Hopefully it'll be interesting, thought-provoking, and if I don't talk about your favorite tool, we can talk about it later. So I'm Andrew. That's very important. That's my Twitter handle. If you want to get in touch with me, you can hit me on LinkedIn, or my DMs are open on Twitter. I like to start with definitions. So if we're going to talk about language, this is the language of infrastructure track. Language, this is just a definition from the dictionary: any system of formalized symbols used or conceived as a means of communicating. And then infrastructure is the basic underlying framework or features of a system. And then code, for this, is a set of symbols that can be interpreted by a computer or a piece of software. So with that, let's go. I want to frame this as clearly as possible. I'm fascinated by language, all sorts of languages, computer programming languages, spoken languages, and I really, really mean I'm fascinated by language. If you don't know what that means, then go read about language games. Because language shapes thought, and thought shapes language in this interesting way. And we don't have the time to go into the Sapir-Whorf hypothesis and some of the different research that has been shown to be in favor or against some of these different framings. But it's just a fascinating study because, at least for me and how I think in words often. And so then when I learn new words, I feel like I can get new thoughts. And it's also, I think it's just a fascinating thing to think about the humanity of language and how all these things sort of grow from each other, and the history of language, at least according to the people who study such things more intently than I do, they really come down to some common things. And it doesn't seem like it on face, but according to the studies, that Hindi, Russian, Spanish, and English are all from this common Indo-European ancestor. So I think that's fascinating too. So I bring this up because I think there's some common themes with the way that the language frameworks will evolve or have evolved till now. So another quick aside, and this also is a part of my fascination with language, is that there's research that suggests that an average human adult can be fluent in a new language in 6 months. They could be fluent in 6 months, and they could be native level speaker in 2 years. And that is provably true, but it's only true if you create these preconditions, these necessary preconditions about how you're going to approach learning it. And then this word necessary is key, because you will only learn languages to the level that you need to. I think that's also true to some degree with the programming languages. We will learn the language, we'll learn a competency with the language to the level that we need to for the tasks we're faced with. This is one of the earliest kind of examples of writing and languages recorded. I think it's funny because it's a table outlining beer rations, and I don't even drink, but I think it's funny because it's like, apparently we drank before we wrote. So infrastructure as code, what does that mean? What does it mean? How do I think about this, or how should you think about it? To me, it's implying that the infrastructure itself is an application, which means that we can use all our software tricks, right? So we can start to think about, software development lifecycle and version control and testing and all this stuff we kind of built up around the process and the agile engineering or what have you, whatever your favorite tricks are. And then it also means that we should be wary of some of our software pitfalls. And I don't necessarily need to go into all these today, but there's a lot of stories where people told their infrastructure as code to do a thing, and it did exactly what it was told, and that took down everything because it didn't go through the life cycle that you would want to with the respect to testing and the rest of it to warrant putting into production. I also think it's interesting when I got this topic and started thinking about it is like, where does the software start and the infrastructure begin? Like, where's the separation? Because it's basically like at the very, very bottom, there's some silicon, and then it's basically software, software, software. So it's abstractions pretty early in the process. A lot of what we call infrastructure, if we're working on kind of business domain applications, it is really software, and it has been for ages, right? So, the kernel is software. All these drivers are software. The provisioning of the resources to start a process is kind of a infrastructure thing, but it's a software process, and I don't think we should forget that. And I think if we internalize that, and the more we understand the things above and below the layer that we're working on, the more we can take advantage of the opportunities we have with the code we're working on. So in the beginning, at least in the Unix world, uh, there was the Bourne shell, right? And this is the interface into the computing, into the processing power. So you have your .sh, and you write some stuff and you tell the computer to do it, and it does it. And in some sense, you could argue that this sort of scripting was this primordial infrastructure as code. And from there, for a hot minute, we could have had Lisp machines, which is funny in its own way, but it was true. That didn't last very long. And then there was Perl. And I'm not necessarily going to leave this up long enough to read the whole thing, but if you've never seen this, it's pretty funny. If you've never seen XKCD, then you should definitely go read some. But the punchline is, God says, honestly, we hacked most of it together with Perl. So this is the story that most people associate with infrastructure as code, or at least most people kind of in my circles, or this kind of beginning of a conversation. And there was a thread recently on Twitter where people were trying to say, what's the origin of infrastructure as code? And we didn't really get to an origin, but we know that we were saying it a lot around, say, 2009, 2008, 2007. I know I said it a lot. And there's this long history. So CF Engine, the first version of CF Engine is 1993, which is like so long ago. And then you kind of come through this notion of infrastructure as code. But in this context, what infrastructure as code means is really the configuration, kind of like the proper care and feeding of servers, keeping servers properly configured through kind of the life cycle of that server. But at least for this kind of paradigm, or this generation of the tools, the server is kind of the highest level primitive, and then any orchestration that you want to do between them, you kind of have to accomplish in this other outside of the abstractions that are provided by those tools, right? And so then it's also interesting when you look at this, that CF Engine is written in C. Then you see these other things getting written in these higher level languages. Puppet, which I know the most about, it was actually an attempt to write it in Perl, and then Python, and then finally Ruby was just the language that Luke was able to express the abstractions that he wanted to. But the construct that most of these are built on, and I'm going to come back to this later because I think this is important, and it's also the basis for lots of stuff with robotics and other types of controls, is this notion of a desired state. So the framework is saying what the desired state is. It's comparing the desired state to the current state, and then there's some logic built into the framework that tries to bring the current state into the desired state. And there's also this notion of, it's like philosophical discussion around imperative versus declarative. And on some level, the way that you get declarative is by getting the right logic to go from the current state to the desired state. But in reality, that's always imperative. So that's the little trick. So you have declarative statements in your language, but reality has time and state, and so then you end up with this imperative work to do that convergence, which will be important in a minute because we're going to come back to control loops. So then, in parallel to this, there's this other story, which I'm conflating, and at least for the sake of this, the containerization and the virtualization, the VMs, as two things that are doing different types of isolation. If you want to go into the details of that, we can do it offline. But for the sake of this discussion, what it means is a proliferation of configurations that need to be managed. And they both have kind of different qualities with respect to the strength of the isolation and the speed that they can be started and how you can move them around and different things. And the features of containers will get more important a little bit later in the story. But this is kind of this, and it's missing lots of other like parts of the story. But this is just kind of like representative. The first virtual machine, there's IBM back in 1972. They proved virtual machines, but didn't really get to be, the hardware itself didn't get fast enough to kind of take advantage of that until about 2000. And then you see this kind of explosion of all these technologies. And then as a consequence of that, and I think this is sort of like the notion of things building on each other, you see very quickly, well, maybe it's not quickly, depends on how you keep track of time, but you see the real explosion of virtualization begin around 2000. By 2006, Amazon launches Amazon Web Service. I think it's also interesting, I'm going to also return to this point, that by say the 2004, 2005, Amazon, Google, any of these sort of cloud natives, what we call cloud natives today, could do that kind of API-driven provisioning inside their data centers. And then 2010, this was I mean, you could basically give an hour-long talk on HashiCorp and kind of I feel like if you have the infrastructure as code lineage with the configuration management from CF Engine through Puppet to Chef to Ansible, then kind of Vagrant's like its own thing. And I mean, the metaphor I would sort of use is Mitchell Hashimoto, sort of like Hamilton, and he's just riding like he's running out of time, coming up with all these crazy tools and abstractions. It's really fun to watch. But I remember when I saw Vagrant the first time, I was like, I used it so much to test Puppet, right? So it's like being able to provision these machines on the cycle was game changing. And so you have this kind of notion of provisioners. So these are these tools that come into the cloud providers and they're able to build infrastructure. And I really, I mean, maybe there's some other ones that are out there, but kind of like Terraform is the one, right? So that's the one that almost everyone seems to use. And then Pulumi is sort of this new entrant that seems to have some momentum as well, but that's kind of that didn't seem to have the Cambrian explosion that some of the other tools did. And this is also around this time, 2015. We'll come back to that date in a minute. You see a lot of the shift towards Go, right? So people are starting to write the infrastructure as code in the Go language. So this is a quick introduction to Wardley, and it's this notion. What I consider like these building on abstractions is things moving from this notion of the genesis, custom built products, up through services, and eventually becoming utility. And you could argue that it's really that this is the story of cloud computing, is computing is moving through this S-curve and becoming a utility. So infrastructure code is moving up the stack. And now you see in the cloud providers all sorts of these higher level services, right? So there's this kind of other stream related to the stuff we're talking about around platform as a service. So you see this timeline of these features where you're able to just push artifacts into the framework. And it's interesting here. So I showed the infrastructure as a service a moment ago, which was provisioning the VMs, but both Google and Microsoft's first foray into cloud computing was really platform as a service. And it's also worth a shout out here. This is sort of the Heroku propaganda that the 12-factor app, to some degree, if you're really paying attention, implies the existence of this 12-factor platform that's going to keep all those promises, right? So if you think about what those 12 factors are, and we could walk through all of them, but not today, then it's like, if you're going to write to a data service, there better be a data service. And then there's Docker, right? So this is like game changing because there's always containers and people were using them, OpenVZ and LXC and the rest of that were things that we used. And we built systems with Puppet and Chef that use those as well. But one of the things that I feel like this was like really insightful was mirroring the artifact of the deployable named shareable image with these defaults that made it accessible to any developer. So before before this, before Docker comes in and kind of like makes it accessible to the average developer, it's sort of difficult and requires a lot of expertise to start a container. And so Docker just like it's basically fixing a usability bug with LXC, and all of a sudden any developer that could install this package can start containers, and not just start them and use them, make them, but share them. And that ability to socialize and share the containers was also, you know, very, very, very game changing. And I think one of the major contributors to how Docker really caught fire. It's again building on, you know, these understandings and this utility, trending from innovation to becoming more and more of a utility. And then I also think it's worth shouting out to this notion of kind of like these Borg-inspired container schedulers, right? So it's like Cloud Foundry, Mesosphere, and Kubernetes, and to some degree Nomad, are all kind of inspired by the Borg. And this is a very similar control loop to what we saw before with the previous generation of tools, but instead of being at the node level, now you're at a service level where the nodes are actually resources inside that control loop. So you say how many nodes there should be, and it makes them. So now it's like Kubernetes, Kubernetes, Kubernetes. That's where we live now. So wait, there's more. There's more stuff, right? So there's all these other things that I think you have to add to the conversation around infrastructure as code, you know, DevOps, continuous delivery, whatever those kind of buzzwords and how they fit together in your head. There's these other things where you kind of write code that's infrastructure-y, and it like delivers these artifacts that then kind of get deployed. So I think you have to shout out to the kind of the cruise control as this beginning, and then, you know, everyone's sort of using Jenkins, but everyone wishes they had something better, but still Jenkins works pretty well. So what are you going to do? And then there's also these data threads, right? So I think if I'm being honest, and you think about like what Hadoop brought to the table, you know, particularly when you talk about Yarn and some of the other stuff, there's really this infrastructure-y, process management, almost platform as a service aspect to that you know really changed the game. And I think each of these sort of NoSQL evolutions, getting into Kafka and some of the newer kind of cloud native databases have an aspect of the infrastructure as code that allows you to manage the lifecycle of those in a meaningful way and keep the promises that you want to about reliability. And then it's like, well, wait a minute, if we're going to talk about data, then like where are we going to stop? And then it's like you get to the cloud native computing foundation, and there's just so much, right? And each one of these is kind of building on that abstraction that came before it, right? So it's like service meshes, and in some sense are very similar to configuration management for the routing. I also think it's interesting to point out that these are patterns. Like every pattern that's in the cloud native computing foundation, you saw in the cloud natives. It was just like they all built the same patterns, just sort of on their own. And now you're seeing them kind of come into this pool, this shared common resource. And sometimes these innovations, right? Like you get a new Genesis and it changes everything above it from there on out. The other thing I think is worth pointing out, and I kind of hinted at this earlier, is this is only the world we can see, right? So there's all this stuff we can't see, and there's, you know, whatever, how you want to think about it, you know, the people that work at Google or at Amazon, they kind of work behind this veil, or, you know, a secret society, if you will, where they see things the rest of us don't necessarily see. They're solving problems that we don't necessarily have. And as a consequence of that, there's this whole world of infrastructure of code that exists in those organizations that we don't necessarily have access to. And I remember a time, you know, 2008, 2009, where if you try to talk to someone that worked at Google about Borg, they would kind of like stop talking to you. That sort of changed now. That the Borg paper's out, and Kubernetes is a thing they've open sourced as sort of an effort to bring that mind share and thought leadership to. But you know, that was a period where they thought the Borg was their secret weapon, and they wouldn't talk to you about it. And you know, there's similar things at Amazon, right? So, you know, they have their framework, they have their platforms, they have all these services, and they're not necessarily sharing, or we don't necessarily know all the tools that they have internally. I mean, I know a little bit, but not as much as I would be able to recreate some of these things. And then also you have to think about the runtimes and the frameworks that are above that. So this is me tweeting. Any sufficiently complicated microservice deployment contains an ad hoc, informally specified bug-ridden implementation of half of Erlang. And each of these, and there's more language frameworks we could go into, have some kind of infrastructure piece to them, right? So it's like Rails migrations, and Erlang does a bunch of things to kind of keep promises with the runtime about reliability. And then we have this kind of what I would consider an attempt to bring lifecycle management to these things that we're managing, installing the architectures, but a lot of these things I consider almost like added on to these things that weren't designed to be cloud native, to try to make them be cloud native so that they can have that life cycle. Whatever the sysadmin would do, we try to encode in these operators or in Habitat or whatever. And that's interesting, but I feel like hopefully we can get past that at some point. And this is me wishful thinking, but I really, I wish we had these abstractions that we could just specify the promises we wanted to keep around scalability and latency, and sort of just declare them, and then the underlying infrastructure would be hidden from us, but it would keep all those promises. That would be awesome. So quick comment about language. Code that works but doesn't reveal its underlying mechanisms and intent is one broken dependency away from being useless. So communicate with other humans, or you at your peril, you won't do that. And you can be fluent in any of this stuff in 6 months if you need to. So, don't get too stressed out that you don't know all this stuff. It's all there for you. This is just stuff in my search I thought was kind of interesting. So Dapper, Swim, RSocket, and WebAssembly are these interesting pieces to build these sort of event-driven architectures, slightly different paradigms from each other, but very interesting. And then there's this infrastructure as a code sort of movement around managing models and a lot of the machine learning stuff that's interesting. And then Dark to me is it's like cloud native Smalltalk. So it's like this integrated environment, basically the IDE and the runtime for the specific paths. So that's kind of an interesting thing. And who knows how these will evolve, but I thought it was interesting. So what comes next? I don't know either, but I'm betting long on computers and humans. So thank you for listening. I'm not here to answer questions. I'm here to have conversations. Thank you.